So this is the 2.5 notes. We're starting off with a quick warm-up about reflections, and then moving on to reflections in lines that are not horizontal or vertical, like the ones we worked on Thursday, and kind of thinking of what we did on Friday to help us start being able to reflect lines that are not vertical and horizontal. So starting with that warm-up, it says, if you know the distance from a point to the line of reflection, explain how you would find the distance from the same point and to its image, and we can draw a picture to model this situation, and then we're answering the question also. So here's a little bit of a drawing, and then we can respond to that question. So if I was to have a coordinate plane here, and I have, say, point A somewhere up here, and from point A, I know that if I was to reflect it over any line, now the ones that we focused on last week were all vertical or horizontal lines. So let's say we have this horizontal line like this. That would tell me then that if I was to flip over that line, it would be the same distance away. So if this is A, then A prime would be down here. And then if I was to connect that, we talked a little bit about that on Friday and talked briefly about it on Thursday, where we say that distance from A to the line of reflection, and then also from A prime to the line of reflection, that's equidistant, or they're the same. So again, this is the line of reflection. And now we're going to go ahead and try to answer the question. So we could say that the distance from the point to the line of reflection will be the same as from the line of reflection to the image. So you can also denote that right in the diagram with those little tick marks to show that that distance from A to the line of reflection is the same as from A prime to the line of reflection, so the image to that. All right, now we're going to jump into the actual notes here, starting with 2.5, and it kind of reminds us at the top there that we want to use the following two facts to perform reflections. And so the first fact says a line containing any point and the image is always perpendicular to the line of reflection. And so we talked a lot about perpendicular, and you guys practiced a lot with writing equations of lines that were perpendicular back from Friday. And we know that the main idea for perpendicular lines is to think of opposite reciprocal slopes. And remember, that means you flip the slope, the original slope, upside down, and you also remove its or change its sign. So if it starts off being positive, it turns negative, and so on. So we're going to use that information first. Then it also says a point and its image are always equidistant to the line of reflection, kind of like what we just wrote down here on the warm-up. So what we're going to try doing here on this first example is try to reflect the point -5, -1 in the line y equals -2/3 x. And so first thing we want to do is let's go ahead and graph that line, and then and also the point, and then from there we'll practice walking through the steps of how to actually reflect it. Back from Friday, we were just practicing with tracing paper, being able to see what happens. Today we want to do it without tracing paper, making sure you know how to follow the steps to be able to do it, because again, for eventually on the quiz and test, you won't have that tracing paper to be able to use that. All right, so let's plot -5, -1, and label that point A. So there's A to start with. Now we want to plot the equation of the line. So remember, when you plot this equation, y equals -2/3 x, the y-intercept there is 0, 0, the origin. There is no b value written down there. And then the slope is -2/3, so that would mean you're going to go up 2 and left 3, or you can go down 2 and right 3. So plot a few points so that we can draw out this line. Oops. So up 2, left 3, or again, down 2, right 3. Okay, and let's go ahead and see what it looks like when we draw this out. Okay, there is my line of reflection. Feel free to use straight edge or ruler to make sure you're drawing your lines properly. For this is the line that we're going to flip over, and notice it's not vertical or horizontal. It has a slope of -2/3. But when we start this problem out, the first thing you want to do is find the opposite reciprocal slope of whatever that line is that we're reflecting over. So instead of -2/3, we are going to flip that, and it's going to become a +3/2. Remove the negative, remember, because we're switching the signs and we're flipping that fraction. So 3/2, that slope, can either mean up 3, right 2, or you could write down, you could also go down 3, left 2. It is up to you which way. You kind of have to look at it and say, how am I going to get closer and closer to the line? So since if I was to try to go down and left, I would go further away from the line. So I don't really care to do that. I want to go up 3 and right 2. And as soon as I do that, I've now landed right on that line. It kind of helps if you want to draw the little like stairs of rise over run. So rising 3, running 2. Okay, now since I did that one time, I would do it again one more time. Up 3, right 2. And you draw that point in, and don't forget to label it A prime. We have now just reflected the point A over the line, or in the line, y equals -2/3 x. That's what the line was, but in order to be able to get the location of the image, I had to make sure I flipped and switched the sign. So I did opposite reciprocal, because as you can see here, if I was to connect from A to A prime, I would have a perpendicular line. So if I want to draw this faintly, you'd see that there would be perpendicular angle, a 90-degree angle between the line of reflection and the line that could connect A and A prime. We'll do the same idea for the second one, and then you'll get some time to practice these, because honestly, the best way to get better with these is just to keep practicing. So the second one here says reflect line segment AB in the line y equals x. Okay, so again, we can draw in that line. The slope is a 1 for that line, and the y-intercept is 0, 0. So here is a +1 for the slope, going up 1, right 1, or down 1, left 1 each time. And then let's go ahead and draw the line there. Okay, now we are going to, again, try to, this time we have point A and point B that we want to reflect over this line of reflection. So we're going to start with, again, identify the opposite reciprocal slope. This slope here is 1. So the opposite reciprocal of that would be -1, because there's no denominator, it's just going to be a 1. And since it was positive, now it's negative. And so this would mean I can either go down 1 and right 1, or I need to go up 1 and left 1. That makes it so that one of the two things are negative. So let's see what happens with point A first of all. If I go down and right, I'll get closer to the line. So that works there. Let's see how I would draw this out. Down 1, right 1. I immediately touch the line. As soon as I do that, I want to continue it one more time. Down 1, right 1. And there is my A prime. For the second one, or for letter B, we do the same thing, but it starts down here. So we want to this time not go down and right, because you're gonna go away from the line. Instead, you want to go up 1, left 1 to get closer and closer to the line. So let's see how many times we do that. Up 1, left 1. Up 1, left 1. That's twice. Up 1, left 1. That's 3 times. But now here's a problem. We go up 1 and we haven't gone left 1, and we've just hit the line. So when that happens, you kind of have to count how many pieces that was, even though it was like half of a piece. So we went up and left once, up and left twice, and up and left 3 times. So 3 full slopes that I kind of used to go up and left, but then I just went halfway. Now you have to still complete it. So since I did up 1, I still have to go left 1. Now I've completed that 1, and now I have to do 3 more, because there was 3 full up 1, left 1s. So from this point here, up 1, left 1, up 1, left 1, that's 2, and finally up 1, left 1, there's 3. And I would call that B prime. I'll write down the coordinates in case you can't really tell exactly what the points are. For A prime, the point here is 3, 1. For B prime, the point here is -5, 2. Okay, and then we can connect them and show that this is now the reflected segment, A prime, B prime. All right, so it should look like that. And actually, just from the last example, in case you weren't sure, A prime on number 1, that first one, is -1, 5, in case you want to double check that point. All right, so that's it for the beginning part, where you're now, where we kind of went through how to actually do the reflections when the lines are not vertical or horizontal. So again, just to recap real quick, the first thing you're gonna do is graph the actual line, whatever the line is, and the plot any points if they need to be plotted. Then take the opposite reciprocal slope of whatever the original was, of the original slope, go ahead and flip it and then switch its sign. That's opposite reciprocal. Use that slope that you just figured out to start going, using your slope to go towards the line, from that point towards the line, and however many times you count that slope. So in this case, it was just once, or on this one, for B, you had to count as many times as we needed to. There was 3 times it went up and left, and then it also did kind of halfway. So we had to make sure we addressed how far that went. If it helps you to draw these little stairs in, feel free to do that. Up and left, and so on. To show that it's the same distance away. There was 3 and like a half, and this is also 3 and then the half that we had to finish up. All right, so you'll get some time to work now on the practice that's on this next page here, and then we'll go through, there's another video, or we can go through it a little bit more tomorrow in class.